Hello, let's look into today's Leetcode problem, which is two best non-overlapping events. So, in this problem, you are given with a certain set of intervals and you want to find a maximum profit out of non-overlapping intervals. By that, what they mean is the input array that they have given with has for each of the elements, we have three values. The first value representing the start index, second value representing the end index, and the third value representing, we can call it as power maybe. Let's see what they have mentioned here. Yeah, value basically. The third element is value for that interval. Similarly, for the other elements as well, first value will be the start time, second value will be the end time, and the third value is the actual value for that interval. So what you want to do is find at max two non-overlapping intervals, which when summed with their corresponding values will give you maximum answer. It can either be one interval and it can also be a total of two intervals that we take into consideration. And the other thing that should be noted here is the start time and end time are inclusive in intervals. So you simply can't, start a second task the moment the previous task ends. So that is something that you should keep in mind. And the other thing is they want at max of two overlapping, non-overlapping events. So this is one more wording that we should catch. Initially, I missed it while coding, but yeah, this is how the problem looks like. So with this, what comes into your mind is we need to select at max two overlapping intervals or events. So you are given with n number of events, you can call it intervals as well. You have to make your choice. You can take any two non-overlapping intervals and you should take it in such a way that it gives you the maximum value. So here you are given with multiple options to select, and at the same time you want to return the maximum profit or sum out of those intervals. So if these two conditions are met of selecting and returning the minimum or maximum, then DP should come into your mind, and that is something that I've used here. Initially I wrote the solution in simple recursive fashion, and if you look into the DP solution, right, this is also recursion, but a memoized version of recursion. So this solution got accepted. So I'll quickly walk you through what actually this means. Maybe I'll take a demonstration and we can proceed forward with the walkthrough of the solution on how to think. Okay, let me jot down the events as well. So we have a total of three events here, and we can actually arrange it in terms of starting order. We can sort it in terms of starting point, starting time basically. So for this array, after sorting, the events should look like this. Okay, we are good with the sorting now. And the second option is either to take or not take. So you can either take this index and go on search for its next non-overlapping index, which in this scenario will be this one. Else, you can simply ignore this index, take this index, and try finding for a non-overlapping interval. Here we don't have any non-overlapping interval, so this should be our answer. But if we take this element, right, then this plus this should be our answer. That is 2 plus 2, which is equal to 4. So that's how we think of doing the solution. Let's try looking into it. But before that, yes, one thing that you should keep in mind is we can only form possible pairs of non-overlapping intervals. So that is something that you should keep in mind. So let's quickly walk through what I've done here, right? So base conditions, as always, we will try to iterate from the starting index and go till the end index. And the other thing is we only want at most of two intervals to be chosen. If any of these conditions are met, then you simply return 0. I'll tell you why 0. Let's ignore this piece of code for now as well. And two things that we can do for a current index, that is either to take it or not take it. For taking an index, we should also pass the next index on which we should perform our search, right? So before that, what we do is for the current index, we are going to find the next index that has its start value greater than the end value. So events of end of 2 is basically the end time of that interval, and sorry, it's basically the value. I've confused here. So events of index of 1 is basically the end time, and you want to find for an index whose start time is greater than that of end time. So all you can do is do binary search. The upper bound will be the answer. You will be able to find the index that is immediately next to or greater than the ending index of current interval. So after you find the next index, right, all you need to do is pass this next index in our helper function. And as we are selecting the current index, we will be adding the value for that interval and perform helper function on the next index. If you are not taking that element, if you are not taking that interval, then you simply go over to the next index instead of finding for next index that is non-overlapping, because you have not taken the current index into consideration, right? So yeah, that's pretty much it. And um, the catch here is to find the next index. So you can simply iterate over. You can simply do linear search and try finding for the index which has its start interval greater than immediate greater than the end interval of current end time of current interval. But we have done binary search here because linear search actually gave me a TLE. So pretty straightforward. You write the usual code for upper bound and you return the index and you put it down in the helper function, and in the end what you want to do is return the maximum value out of take and non-take, and that will be our answer. Here the additional thing that I have done here is memoize the solution. I have declared a DP of size event dot size plus one, just to be on the safer side. You can simply ignore it as well. Uh, so yeah, so the other thing that is necessary here is to do sorting. So here the sorting is done default, that is on the starting index. Only after you do sorting, that is when you can do binary search and try to find out an index which is immediately greater than the end time of current interval, right? So this is important, necessary, whatever you may call it. And yeah, that's it. If you are able to understand this question, then well and good. It is actually a simple question only, a simple DP classic question with a little bit of optimization that we do using binary search. It actually, you can represent it like a variation of longest increase in subsequence as well. Here what we try to do is try to find the next interval which is greater than that of the current interval's end, right? You can do that as well. But this solution will give you optimum answer because we are doing a binary search, unlike in normal LIS question we actually do a binary search there as well, but the use case over there is different. Okay, so yeah, thanks for watching. Bye bye.